Professor Roger Barlow, perhaps you could just put things into context and explain your current role and your background in particle physics.
I am currently, as you know, the director of the Institute for Accelerator Applications here in Huddersfield, but I was and still am a particle physicist. I'm not one of the people that worked on the experiments that discovered the Higgs, but I have worked on many experiments that failed to discover the Higgs over the past God knows how long in Germany, in Geneva, in America. We didn't make a discovery, but at least we got some publications out of it. Today is just the icing on the cake. The big breakthrough came last year when the particle was actually found and we knew the idea had been right all along. You want me to explain what the Higgs boson is in 2 minutes? I will do my best. In 1960s, which was before I was around, we had this beautiful theory which just didn't work. And Higgs and Brout and Engler showed how to make it work by adding this extra field.
So what was missing from this model? What was the thing that didn't work?
The particles behaved as they should, but they all had zero mass and had to have zero mass. And this mechanism showed how to break the symmetry which would then allow particles to have mass without violating the rulebook.
So we know that particles have mass, but the maths at the time didn't provide any mechanism for it.
Absolutely. You see, the photon, the light particle, has got zero mass. And this was a theory which said, well, these other particles, these W's and Z's, they're like photons. But the W's and Z's had non-zero mass, as do other particles. And Higgs showed how to break that. And Higgs, I think it's now the dust has settled and the jury's out. This was a discovery that came through cumulative work of a lot of people. Kibble, Anderson and others, as well as Higgs and Brown and Engler. But those were the three that specifically laid out how the mechanism was broken. And Higgs was the one who actually wrote down, and this means that there will be a particle associated with this field. So I think it's right that he gets his name on the particle, but the three of them, of whom only two are alive now, which is why there's only 2 prizes awarded, get their name on the mechanism. And it's a beautiful example of how pure thought, just somebody scribbling down bits of equations in a formula, can lead to massive accelerators, massive detectors, thousands of people working, lots of concrete and steel electricity on the ground, and as a result we finally know that it's there. And the Nobel Prize, this is a chocolate one, he'll be getting the real one. The Nobel Prize is just the icing on the cake. They've got the esteem of his colleagues and the scientists already.
So, job done? Nothing left to do in physics?
No, it's as usual, you answer one question, you raise a whole lot more. We don't understand why this field has the form that it has. We don't understand why the mass is so different from other masses. There's a lot more of unanswered questions, but we have come to an end of a chapter.
Professor Roger Barlow, thank you very much.
Thank you.
The University of Huddersfield, inspiring tomorrow's professionals.